Hi everybody, this is Shailesh and welcome to my channel Quantum Intelligence. And first of all, a very happy new year to all of you. In this channel, I aim to do basically a deep research in areas like blockchain, AI, and also in quantum computing. Basically, quantum computing and how it affects in the decentralized systems. So, in the coming days, I will be uploading videos related to the different research papers that I review and also show some codes of how those different research areas are getting implemented. And first of all, before getting into more other details, I would like to start discussing about the UTXO based systems and account based systems actually. Yes, the UTXO based systems are basically the Bitcoin or the Cardano blockchain, where it's basically a cash based accounting that happens where there are no states there, and also the programmability or the Turing based things are very less. You can say you will not be able to develop easily the smart contract programs as you develop in the account based systems, which are something like Ethereum and Solana and the other blockchains which follows the account based systems. And in the coming days, I'll be showing you the more differences between the UTXO and account based systems, how the structures are and where are the actual differences that happens. Yeah. So, but by I would like to give a brief overview about it as of now. Like in UTXO-based systems are very much secure, or you can say it like since it doesn't have the states or it doesn't have the unnecessary complications, it's said to be very much secure, and most of the transactions that happens are also mostly confidential, because let's say if Alice transfers something to a different user like Bob, that particular coins are, let's say, like out of 1,000, if 100 coins are being transferred, the 900 coins which are the balance that will be there, but you will be able to pinpoint which 100 coins have been transferred to the Bob. So that's a specialty of UTXO, because in each transfer you will be able to store the necessary informations of which coins were transferred. But in account-based systems, which follows the banking-based systems, like how we do with banks, there you don't keep the necessary informations of which coins were transferred. So that's the basic general thing. And then the thing is that in Ethereum or the decentralized systems, which follows the account-based models, you will everybody will be able to see the whole transactions that's happening, like what is the balance of Alice, what is the balance of Bob, whichever the users are using it, everything can be seen. So the privacy is a bigger problem there. So how we overcome that particular problem, that's what I'm trying to discuss in this video. So if you have any questions, please place your comments in this YouTube section. Uh, yeah, so as you see in this website, you can see that Alice is transferring some coins to Bob. Now, how the privacy issues can be solved? One is like, yeah, you are not encrypting anything here. So, first thing is that Alice has to use his or her public key to encrypt that particular input which is being passed on to Bob, and then it has to generate the ZK proofs of it, like whether the encryption was right or not. And the encryption, once it is done, the ZK proofs are done. I mean, it has to follow the Peterson commitment schemes for that. And then you follow the, I mean, the ZK has to follow the bullet proofs. So more details we will be able to discuss when we discuss each and every research paper related to this. So for now, it's about the twisted LGML encryptions, which is said to be as much more secure, because LGML encryptions, without the LGML encryptions, it is not that compatible with the range proofs or the bullet proofs. So the thing is, for that to make it compatible, we need to be using the twisted LGML encryption. So that's the brief overview that I want to say. But later, when we research the specific papers, I'll be able to show you that what are the advantages of this twisted LGML encryptions. And it follows the Peterson commitment scheme, and then using that, yes, the ZK proofs are generated, which can be verified, and which can be verified by any type of users. Like, yes, of course, the receiver will be able to verify it. The thing is that, yes, was the decryption is done, you have some other external users also here, like auditor and supervisor, because since the transactions are being passed in the encrypted state or into the encrypted format, no other user will be able to decrypt it, because the secret keys are with either with the Bob or with the auditor or the supervisor. So the auditor, he will be able to view the transactions, because of course the auditor should be there, where if it's in a bank or if it's in any particular industry, they need to validate it, or they need to review all the transactions which is happening, whether it is according to their specific policies or not. And so for that, the auditor has to uh, see the data, that is the proofs. I mean, the proofs are valid or not, that needs to be verified. Without seeing the exact data, auditor will be able to verify that. So auditor, using the company policies or using his policies, he will be able to pass the inputs into the proof, and if it is getting verified, I mean, if it is getting passed, then the verification is successful for the auditor. So the same thing with the supervisor also. Supervisor could be, the difference between auditor and supervisor is that auditor, with the concern of the users only, he'll be able to check the transactions, check the status of the transactions. But the supervisor, without the consent of the users, he or she will be able to they monitor the transactions. So that because supervisor is something like a boss, and auditor could be like an entity which will need permissions from the users who are sending the transactions, and based on that, the auditor does that. So basically, it means that the Bob, the receiver, if he needs to say that, yes, I got the corresponding amount and the transactions are complete. For that, the thing is that he needs to decrypt it based on the private key that is given. And yes, in this case, it is not that complicated, because it's just a one transfer coin. But you can think, like, if it is a smart contract and if you have a group of transactions that is getting executed, then the Bob will not be the only guy that will be doing the execution of smart contract. There will be a centralized MPC committee which will execute those smart contract logics, and for that, you need to what you say, decrypt the transactions. Let's say, like, it is encrypted using the twisted LGML encryption, and the same thing needs to be decrypted using the threshold LGML decryption. And once that is done, with the group of MPC parties, the smart contracts will be executed between the parties. So for that, of course, there is an different levels of mathematical algorithms that we need to use, like additive homomorphic encryption mechanisms, and also how we improve the multiplications, and how we employ the multiplications on top of the encrypted data that is being coming from the Alice. So that those all things we will be discussing in the coming videos, as there will be an MPC circuit with different levels of logics. So it depends on like how you want to design the MPC circuit, whether it has to be a semi-honest or like a malicious circuit with the abort conditions. So all these things, there are different levels of that that we can discuss, and I'll be discussing that in the coming videos. So basically, yes, when you want to make this into a confidential transaction, you will need to encrypt the data, and there should be ways to decrypt it when the receiver receives that input, and he wants to update the ledger accordingly. So that's what I want to say here. And next thing is that if you don't want to show the users wallet addresses, you can do it in the form of an anonymous transfer. And for that anonymous transfer, which means that you are hiding the user's details, for that you need to use the ring signatures for that, which will be something like out of a group. The encryptions of the addresses will be done, and based on that, based on the ring signatures, actually the transactions will be taking place. So either using that or using the stealth addresses, you will be able to get into the anonymous mode of transactions where you hide the user's details. So here we have the two things: one is the confidential, and another one is the anonymous transactions. So these are the things that I want to discuss, and the things that we discussed in the previous diagram, that will be discussed in detail using these research papers like ZK Ledger, Zeta, Rathel, and Eagle. Actually, these are the research papers that I've identified for this topic. That means that for confidential and for anonymous transactions. Yeah. So thank you for watching this video. Thank you.